So in this question, we are asked to find the height by which the outer rail of a curve should be raised when a train moves around it. So let's break this down step by step. Okay, first, let's understand the problem. Logically, imagine a train moving on a curved track like a car on a bend. If the track is flat, the train might tip over because of gravity and the curve, right? To help the train stay balanced, we need to raise the outer rail a little bit higher than the inner rail. So, the height of the outer rail needs to be raised uh, is based on how fast the train is going and the radius of the curve and the distance between the rails. So there's a formula for this known as the banking angle formula. So the formula is tan theta is equal to v square by to r, where v is the speed of the train, g is the acceleration due to gravity, r is the radius of the curve, and theta is the banking angle or the height difference between the rails. So let's plug in the values for the equation into the formula. The speed of the train is 12 meters per second, so 12 square. G is 10 meter per second as given in the question, into R into 400. Right. So solving this, we get tan theta is equal to 0.036. Okay. So to find the height, we need to use the relation height is equal to distance between the two tracks into tan theta. So basically it is, if this is your theta, this is your height, and this is your distance between the two tracks. So tan theta will be h by d and h will be distance into tan theta. So the height will be 1.5 into 0.036, which is equal to 0.054 meters, which is equal to 5.4 centimeters, and option 2 is the right option. Okay.